Right now, airports across Asia are implementing emergency health screenings. Thailand, Singapore, Malaysia, Hong Kong. All of them scanning passengers for symptoms of a virus that kills up to 70%, with some saying as high as 75% of those it infects. 2 confirmed cases in India, nearly 200 people quarantined. The virus is Nipah, and if you haven't heard of it, there's a reason. The fatality rate is so high that outbreaks typically burn themselves out before spreading widely. But this time feels different. This is the first time India has seen cases in nearly 20 years. The virus jumps from fruit bats to humans, sometimes through pigs, sometimes through contaminated food. There is no vaccine. There is no specific treatment. And the World Health Organization has listed it as one of the top priority pathogens that could cause the next global pandemic. What they're not telling you is why this outbreak is happening now, in a region where Nipah was thought to be contained, and what it means that multiple countries are preparing for something they hope won't come. If this sounds like the beginning of something we've seen before, make sure you subscribe and turn on notifications, because what I'm about to explain will show you why health officials are more concerned about this than they're letting on publicly. Let's start with what we know for certain about what's happening right now in India. West Bengal, India. 2 confirmed cases of Nipah virus. That's all it took for nearly 200 people to be placed under quarantine. That's all it took for airports across multiple countries to activate emergency protocols. 2 cases, because when a virus kills 40 to 75% of the people it infects, 2 cases is not a small number. 2 cases is a potential catastrophe waiting to unfold. Let me put this in perspective. COVID-19, at its worst with early strains, had a mortality rate around 1 to 2%. That was enough to overwhelm hospitals, crash economies, and kill millions globally. Nipah virus has a mortality rate that's 20 to 75 times higher, depending on the outbreak. This isn't a virus that makes you sick. This is a virus that, more often than not, kills you. And here's what makes this particularly terrifying. The 2 cases detected in West Bengal are the first India has seen in nearly 20 years. 20 years of silence. 2 decades where the virus seemed to stay in its reservoir, where outbreaks were limited to other regions, where India appeared to have dodged this particular bullet, and now it's back. The response has been immediate and aggressive. Authorities have quarantined nearly 200 people who may have come into contact with the 2 infected individuals. This isn't a precautionary measure. This is damage control. Because with Nipah, you don't get second chances. You don't get to wait and see if more cases develop. By the time you see widespread transmission, it's already too late for many of those infected. Contact tracing for Nipah is different than for most viruses. With COVID, you traced contacts because the virus spread easily, but killed relatively few. With Nipah, you trace contacts because even though it doesn't spread as easily, when it does spread, the outcome is often fatal. Every contact is a potential death. Every missed connection is a potential outbreak. The quarantine isn't just about the 200 people in isolation. It's about the thousands of people those 200 might have encountered before they were identified. It's about the exponential math of disease transmission, where 2 becomes 4, becomes 8, becomes 16. Except with Nipah, that exponential growth isn't just case numbers, it's potential deaths. Here's what the news coverage isn't emphasizing enough. This outbreak is occurring in West Bengal, a densely populated state with over 90 million people. Population density matters enormously with infectious diseases. The more people packed into a smaller area, the more opportunities for transmission. The more difficult it becomes to isolate cases and trace contacts effectively. And West Bengal isn't just densely populated, it's also a region with significant agricultural activity, including fruit cultivation. That matters because Nipah's primary reservoir is fruit bats. These bats are common across South and Southeast Asia. They feed on fruit, particularly date palm sap, and in the process, they contaminate food sources that humans then consume. The virus doesn't need to jump from bat to human through some rare, unlikely event. It happens through ordinary activities, drinking fresh date palm sap, eating fruit that bats have bitten. These are normal parts of life in rural areas of West Bengal, which means the opportunities for transmission are constant, ongoing, and difficult to eliminate without fundamentally changing how people live. But here's the part that should concern you most. According to health officials, they believe the outbreak is now contained. 2 cases. Nearly 200 quarantined. Situation under control. Except we've heard that before, haven't we? We've heard authorities declare outbreaks contained only to watch them explode weeks later. We've learned the hard way that confidence in containment is often premature. The difference is that with most viruses, premature confidence means more cases, more hospitalizations, more strain on healthcare systems. With Nipah, premature confidence means mass casualties. Because there is no treatment, there is no vaccine, there is only supportive care, keeping patients alive long enough for their immune systems to fight off the infection. And with a 40–75% fatality rate, most immune systems lose that fight. So when officials say the outbreak is contained, what they're really saying is, we hope we caught it in time. We hope we identified every contact. We hope the virus hasn't already spread beyond our quarantine perimeter. We hope this doesn't become the outbreak we've been dreading for decades. Hope is not a strategy, but with Nipah, hope is often all you have. While India manages its outbreak, something else is happening, something that tells you how seriously regional health authorities are taking this threat. Airports across Asia have activated emergency health screening protocols. Thailand, Singapore, Malaysia, Hong Kong, all of them are now screening passengers for symptoms associated with Nipah virus. Let me be clear about what this means. Airport health screenings are expensive, logistically complex, and disruptive to travel. They require trained personnel, specialized equipment, and coordination across multiple agencies. Countries don't activate these protocols lightly. They activate them when the risk of importation is high enough to justify the cost and disruption. The fact that multiple countries activated screening simultaneously tells you something important. It tells you that behind closed doors, in meetings the public doesn't see, health officials are more worried than their public statements suggest. It tells you that the risk assessment is higher than what's being communicated in press releases. Think about the geography here. West Bengal borders Bangladesh. It's not far from Nepal, Bhutan, and Myanmar. The region is interconnected through trade, travel, and migration. People move across borders constantly for work, family, commerce. A virus that emerges in West Bengal doesn't stay in West Bengal. It travels. And that's why airports in Thailand, Singapore, Malaysia, and Hong Kong are screening. Because they know that in our interconnected world, a virus detected in India today could be on a plane to Bangkok, Singapore, Kuala Lumpur, or Hong Kong tomorrow. The incubation period for Nipah is 4 to 14 days. That's plenty of time for an infected person to board a plane, travel internationally, and arrive in another country before symptoms appear. Airport screening isn't perfect. Thermal scanners can detect fever, but not everyone with Nipah develops fever immediately. Questionnaires rely on passengers being honest about their symptoms and travel history. Visual inspections can miss early-stage infections, but imperfect screening is better than no screening when you're dealing with a virus this deadly. Here's what the screening protocols are looking for: fever, headache, vomiting, respiratory symptoms, altered mental status. These are the early signs of Nipah infection. The problem is that these symptoms are also common to dozens of other illnesses: flu, COVID, dengue, malaria. Distinguishing Nipah from other causes of fever and headache requires laboratory testing, which takes time, so the screening process becomes a triage system. Identify passengers with symptoms, isolate them, test them, and hope that the vast majority test negative for Nipah while you wait for results. Because every hour of delay is an hour where a potentially infected person could be transmitting the virus to others. But here's the uncomfortable reality that health officials understand but rarely say out loud. Airport screening is theater as much as it is medicine. It makes people feel safer. It demonstrates that authorities are taking action. It creates a visible barrier between the outbreak zone and the rest of the world. But its actual effectiveness at preventing importation is limited. Studies of airport screening during previous outbreaks, including SARS and Ebola, have shown that most imported cases are not detected at airports. They're detected days later when symptoms develop and patients seek medical care. The screening catches some cases, but it misses many others. So why do it? Because even catching some cases is better than catching none. Because the alternative, doing nothing and hoping infected travelers don't arrive, is politically and ethically untenable. And because in the early stages of an outbreak, when you don't yet know how bad it's going to get, you implement every measure available, even imperfect ones. The fact that multiple countries activated screening tells you they're preparing for the possibility that this outbreak is larger than the 2 confirmed cases suggest. They're preparing for the possibility that there are undetected cases in India. They're preparing for the possibility that someone infected is already traveling, already on a plane, already en route to their country. This is the calculus of pandemic preparedness. You hope for the best, you prepare for the worst, and you implement measures that might seem excessive in hindsight if the outbreak fizzles out, but that will seem inadequate if it explodes. Right now, we're in the hoping phase, but the preparations tell you that health officials are not confident in that hope. Let me walk you through what happens when Nipah virus enters the human body, because understanding the disease mechanism helps you understand why the fatality rate is so high and why there's no effective treatment. Nipah is a paramyxovirus in the same family as measles and mumps, but unlike those relatively manageable childhood diseases, Nipah has evolved to be extraordinarily lethal. The virus targets specific receptors called ephrin B2 and ephrin B3, which are found on the surface of cells lining blood vessels and, critically, neurons in the brain. When Nipah enters your body, usually through consuming contaminated food or through close contact with infected animals or people, it begins replicating in your respiratory tract. The initial symptoms are flu-like: fever, headache, muscle pain, vomiting, sore throat. At this stage, you might think you have a bad cold or flu. You might not seek medical care. You might continue your normal activities, potentially exposing others. This prodromal phase lasts anywhere from 3 to 14 days. But then something changes. The virus crosses the blood-brain barrier. This is the critical moment. This is when Nipah transforms from a respiratory illness into a neurological catastrophe. Once in the brain, the virus causes acute encephalitis, severe inflammation of brain tissue. Your brain begins to swell. The swelling occurs inside your skull, which is a rigid container that cannot expand. As pressure builds, brain tissue gets compressed, blood flow decreases, neurons die. The symptoms of this neurological phase are terrifying: dizziness, drowsiness, altered consciousness. Patients become confused, disoriented. They may not recognize family members. They may become combative or agitated. Seizures are common. And then, within 24 to 48 hours of neurological symptoms appearing, many patients slip into a coma. The coma is not peaceful. It's the brain shutting down under the assault of viral replication and inflammatory response. Doctors can provide supportive care, mechanical ventilation to keep patients breathing, medications to reduce brain swelling, but there is no antiviral drug that effectively targets Nipah. There is no way to stop the virus once it's in the brain. Some patients survive. Their immune systems mount an effective response. The inflammation subsides. They wake from the coma. But survival doesn't mean recovery. Many survivors are left with permanent neurological damage, personality changes, memory loss, seizure disorders. The virus scars the brain in ways that don't heal. And here's the truly horrifying part. Even if you survive the acute infection, even if you recover and go home and resume your life, the virus can reactivate. We have documented cases of relapsing encephalitis, where patients who recovered from Nipah months or even years earlier suddenly develop brain inflammation again. The virus, dormant in the central nervous system, reactivates and causes a second, often fatal, episode. This is not a virus you recover from and forget about. This is a virus that can kill you twice. Compare this to COVID-19. COVID primarily attacks the respiratory system. It can cause severe pneumonia, acute respiratory distress syndrome, and death. But the mechanism is different. COVID kills through respiratory failure, through the lungs filling with fluid and being unable to oxygenate blood. It's terrible, but it's a mechanism we understand and can sometimes manage with ventilators and oxygen therapy. Nipah kills through brain destruction. There's no ventilator for your brain. There's no way to oxygenate neurons. Once the virus is in your central nervous system, you're in a race between your immune system and viral replication. And with a 40-75% fatality rate, the virus wins more often than not. The survivors, the 25 to 60% who make it through often wish they hadn't. The neurological sequelae, the long-term effects, can be devastating. Imagine surviving a virus only to discover you can no longer remember your children's names, or that you have seizures multiple times a day, or that your personality has changed so fundamentally that your family no longer recognizes who you are. This is what Nipah does. This is why health officials are terrified of it. Not just because it kills most of the people it infects, but because even survival can be a form of tragedy. To understand why Nipah is so feared, you need to know the story of how it was discovered, because the 1998 outbreak in Malaysia was a wake-up call that the world largely ignored. It started in a small village called Sungai Nipah, which is where the virus gets its name. Pig farmers began collapsing. They developed high fevers, but unlike typical flu, they became aggressive, confused, unable to balance. Then the seizures started. Doctors initially thought it was Japanese encephalitis, a mosquito-borne disease common in the region. They sprayed for mosquitoes. The cases kept rising. It wasn't until a diligent researcher examined tissue samples under a microscope that they realized this was something entirely new. It wasn't coming from mosquitoes, it was coming from the pigs. But the pigs were just the intermediate host. The true reservoir was fruit bats, specifically flying foxes, large bats that feed on fruit. The bats would eat fruit in trees hanging over pig pens. They would drop half-eaten fruit contaminated with saliva and urine into the pens. The pigs would eat the contaminated fruit. The virus would replicate in the pigs, reaching high concentrations, and then farmers, in close contact with their pigs, would become infected. The outbreak was stopped only through the tragic culling of over 1 million pigs. An entire industry was devastated. Farmers lost their livelihoods. But the virus was contained, or so everyone thought. The virus didn't disappear. It retreated back into the bat populations, where it circulates naturally without causing disease. Bats are the perfect reservoir for Nipah. They carry the virus without getting sick. They live in large colonies where the virus can spread easily, and they have extensive ranges that overlap with human populations. Since 1998, we've seen sporadic outbreaks in Bangladesh and India, specifically in the Kerala region. And here's where the story shifts from pig farming to something much harder to control. In these later outbreaks, there were no pigs involved. The virus jumped directly from bats to humans. The transmission route was through a local delicacy, raw date palm sap. People place clay pots on palm trees overnight to collect the sweet sap. The bats, attracted by the sugar, fly to the pots, drink from them, and urinate or defecate into the sap. The next morning, people drink the fresh juice, ingesting a massive viral load directly. This is the nightmare scenario for disease control. You can cull pigs, you can eliminate an intermediate host, but you can't eliminate bats. They're ecologically essential. They pollinate plants, disperse seeds, control insect populations, and you can't easily change cultural practices around food consumption, especially in rural areas where date palm sap is a traditional and economically important product. So the virus persists. It circulates in bat populations. And periodically, when conditions align, when a bat colony is stressed, when viral shedding increases, when human behavior brings people into contact with contaminated materials, the virus jumps and people die. The 1998 outbreak killed over 100 people. Subsequent outbreaks in Bangladesh have had even higher fatality rates, sometimes exceeding 75%. Each outbreak is small, usually fewer than 50 cases, because the virus doesn't spread easily between humans. But each outbreak is devastating for the communities affected, and each outbreak is a reminder that we have not solved this problem. We have not developed a vaccine, we have not created effective treatments, we have not eliminated the transmission routes. We have simply been lucky that the outbreaks have remained small and geographically contained. But luck runs out. And the question health officials are asking right now, as they watch the West Bengal outbreak unfold, is whether our luck is running out now. Here's the uncomfortable truth about Nipah virus. We could have a vaccine by now. We could have treatments. We have the scientific knowledge and technological capability. What we don't have is the economic incentive. Nipah outbreaks are small. They occur in poor, rural areas of developing countries. The total number of cases globally since 1998 is in the hundreds, not millions. From a pharmaceutical company's perspective, developing a vaccine for a disease that affects hundreds of people is not profitable. The research and development costs are enormous. The regulatory approval process is lengthy and expensive, and the market is tiny, so no major pharmaceutical company has invested in Nipah vaccine development. The work that has been done has been funded by governments and nonprofit organizations, and it's been slow. There are candidate vaccines in early-stage trials, but none are close to approval for widespread use. This is the dark side of market-driven medicine. Diseases that affect wealthy populations get massive investment. Diseases that affect poor populations get neglected. It's not a moral judgment on pharmaceutical companies. It's simply the reality of how the system works. Companies need to make money to survive. Vaccines for rare diseases in poor countries don't make money. The same logic applies to treatments. There is no specific antiviral drug for Nipah because developing one would be expensive and the market would be small. The only treatment available is supportive care, mechanical ventilation, medications to reduce brain swelling, management of seizures. Doctors keep patients alive and hope their immune systems can clear the virus. There have been compassionate use trials of monoclonal antibodies, specifically one called M102.4, which showed some promise in animal studies. But access to these experimental drugs is extremely limited and usually not available in the rural areas where outbreaks occur. By the time a patient is sick enough to need experimental treatment, they're often too sick for it to help. This creates a terrible inequality. If Nipah were circulating in New York or London or Tokyo, we would have a vaccine within months. We would have multiple treatment options. We would have massive public health campaigns and unlimited resources devoted to containment. But because Nipah circulates in rural Bangladesh and India, it remains a neglected disease. The World Health Organization has tried to address this by creating a priority pathogen list, diseases that pose a significant threat to global health and that need accelerated research and development. Nipah is on that list, but being on a list doesn't automatically generate funding or speed up vaccine development. It's a recognition of the threat, not a solution to it. And here's the truly frightening part. The lack of vaccines and treatments means that if Nipah ever does evolve to become more transmissible between humans, if it ever develops the ability to spread as easily as COVID while maintaining its 40 to 75% fatality rate, we would be facing a catastrophe with no medical countermeasures available. We would be back to medieval plague responses: isolation, quarantine, and prayer. In the 21st century, with all our medical technology and scientific knowledge, we would be helpless against a virus we've known about for over 25 years. That's not a failure of science. That's a failure of priorities. That's a failure of the systems we've built to protect public health. And it's a failure that could cost millions of lives if we're unlucky. Let me walk you through the scenarios that keep epidemiologists awake at night. Because the West Bengal outbreak, small as it currently is, represents a branching point. A moment where the future could go in very different directions depending on what happens in the next few weeks. Scenario 1. Containment succeeds. The 2 confirmed cases are isolated. The 200 quarantined contacts remain healthy. No new cases emerge. After 14 days, the maximum incubation period, the quarantine is lifted. The outbreak is declared over. Life returns to normal. This is the best case scenario. This is what everyone is hoping for. Scenario 2. Limited spread. A few of the quarantined contacts develop symptoms. They're quickly isolated. Their contacts are traced and quarantined. The outbreak expands to perhaps 10 to 20 cases total. The fatality rate is high, maybe 50-60%, so 5-10 people die. It's tragic for those families, but the outbreak remains contained within West Bengal. It doesn't spread to other states or countries. Eventually, it burns out. This is a bad scenario, but manageable. Scenario 3. Regional spread. The virus escapes the quarantine perimeter. Cases appear in other parts of West Bengal, then in neighboring states. The outbreak grows to 50-100 cases. Contact tracing becomes overwhelmed. Hospitals fill with patients needing intensive care. The fatality rate remains high. Panic begins to spread faster than the virus. Travel restrictions are implemented. Economic activity slows. This is a serious scenario that would require national-level response. Scenario 4. International spread. An infected person travels before symptoms appear. They board a plane to Bangkok, Singapore, or Hong Kong. They develop symptoms after arrival. They've exposed everyone on the plane, everyone in the airport, everyone they've had contact with in the destination country. New outbreaks spark in multiple countries simultaneously. This is the nightmare scenario. This is what the airport screenings are trying to prevent. Scenario 5. The unthinkable. The virus mutates. It becomes more transmissible between humans while maintaining its high fatality rate. What was a sporadic, limited outbreak becomes a pandemic. This is the scenario that justifies Nipah being on the WHO priority pathogen list. This is the scenario that would make COVID look mild by comparison. Right now, we're in scenario 1, hoping it stays there. But hope is not a plan, and the history of infectious disease outbreaks is full of moments where hope failed and scenarios escalated faster than anyone expected. The challenge with Nipah is that the window for effective intervention is narrow. By the time patients develop neurological symptoms, they're often already too sick to save. By the time an outbreak is recognized, the virus may have already spread beyond the initial cases. And because there's no vaccine to protect contacts and no treatment to save patients, every case is a potential death, and every death is a tragedy that could have been prevented with better surveillance, faster response, or medical countermeasures that don't yet exist. So what happens next depends on factors we can't fully control. It depends on whether the virus has already spread beyond the known cases. It depends on whether infected individuals travel before being identified. It depends on whether the virus mutates in ways that change its transmissibility. And it depends on whether the public health response is fast enough and comprehensive enough to stay ahead of the outbreak. We'll know more in the coming weeks. The incubation period is 14 days. If we don't see new cases by mid-February, that's a good sign. If we do see new cases, especially in locations far from West Bengal, that's a very bad sign. For now, we wait, we watch, and we hope that this outbreak follows scenario 1 and not scenarios 3, 4, or 5. Let me be practical here. If you're watching this from outside South Asia, your immediate risk from Nipah is extremely low. The virus doesn't spread easily between humans. It requires close contact with infected individuals or animals. It's not airborne in the way COVID is. You're not going to catch Nipah from someone walking past you on the street. But if you live in or plan to travel to South or Southeast Asia, there are precautions you should take. These aren't panic measures. These are sensible steps based on how the virus transmits. First, avoid consuming raw date palm sap or toddy in areas where Nipah is known to circulate. If you must consume these products, make sure they've been boiled. Heat kills the virus. A simple boiling step eliminates the risk. Second, avoid contact with sick pigs or bats. If you work in agriculture or live in rural areas where bats are common, be aware of the risk. Don't handle sick or dead animals. Don't consume fruit that shows signs of bat bites or scratches. Third, practice good hygiene. Wash your hands frequently. Wash fruits and vegetables thoroughly before eating. These are basic precautions that reduce risk for many diseases, not just Nipah. Fourth, if you develop fever, headache, and confusion after potential exposure, seek medical care immediately. Tell your doctor about the exposure. Early supportive care improves survival rates, even though there's no specific treatment. And fifth, stay informed. Follow updates from the World Health Organization and local health authorities. If the outbreak expands, travel advisories may be issued. Take them seriously. For health workers, the precautions are more stringent. Nipah can spread through contact with infected bodily fluids. Healthcare workers caring for Nipah patients need full personal protective equipment: gowns, gloves, masks, eye protection. The virus has killed nurses and doctors in previous outbreaks. Infection control is critical. But here's the broader point. Individual precautions matter, but they're not enough. What we really need is systemic change. We need investment in vaccine development for neglected diseases. We need better surveillance systems to detect outbreaks early. We need rapid response capabilities to contain outbreaks before they spread. And we need to address the ecological factors that bring humans into contact with wildlife reservoirs. That last point is crucial. Nipah outbreaks are a symptom of a larger problem: habitat destruction. As we cut down forests for agriculture and development, we push wildlife into closer contact with human populations. Bats that once lived deep in forests now roost near villages. The buffer zones that used to separate wildlife and humans are disappearing. This is the One Health concept. Human health, animal health, and environmental health are interconnected. You can't solve Nipah without addressing deforestation. You can't prevent future outbreaks without preserving ecosystems. The virus isn't the enemy. The virus is just doing what viruses do. The enemy is the system that brings humans and viral reservoirs into contact. Until we address that, we'll continue to see sporadic outbreaks. We'll continue to lose lives to a virus we've known about for 25 years. And we'll continue to hope that the next outbreak doesn't become the pandemic we've been dreading. As we close, I want to leave you with the questions that should be asked but aren't. Questions that make people uncomfortable because they don't have easy answers. Why did this outbreak happen now? West Bengal hasn't seen Nipah in 20 years. What changed? Is it ecological? Is bat population stress increasing viral shedding? Is climate change altering bat behavior and bringing them into closer contact with humans? Or is it surveillance? Are we just detecting cases now that we would have missed 20 years ago? Why are multiple countries implementing airport screening for just 2 confirmed cases? What do health officials know that they're not saying publicly? Is there intelligence suggesting the outbreak is larger than reported? Are there suspected cases that haven't been confirmed? Or is this simply an abundance of caution? What happens if the virus mutates? Nipah has a relatively stable genome, but all viruses mutate. What if it develops the ability to spread more easily between humans? What if it becomes airborne? We have no vaccine, no treatment, and a 40-75% fatality rate. What's the plan? And most importantly, why haven't we developed a vaccine in 25 years? We've known about Nipah since 1998. We've seen multiple outbreaks. We know it's on the WHO priority pathogen list. Why hasn't there been a Manhattan Project-level effort to develop medical countermeasures? The answer to that last question is uncomfortable. It's because the people dying from Nipah are poor, rural, and politically powerless. They don't have lobbyists. They don't have advocacy groups with massive budgets. They don't live in countries that can pressure pharmaceutical companies or fund large-scale research programs. So they die. And we watch. And we hope it doesn't spread to places where people have more political and economic power. Because if it does, suddenly the resources will appear. Suddenly the vaccine development will accelerate. Suddenly it will become a priority. That's the truth nobody wants to say out loud. But it's the truth nonetheless. The West Bengal outbreak will likely be contained. The 2 cases will probably not become 200. The airport screenings will probably not detect any imported cases. And in a few weeks, this will fade from the news cycle. Life will go on, but the virus will still be there, circulating in bat populations, waiting for the next opportunity to jump to humans. And we'll still have no vaccine, no treatment, no solution. Until we do. Until the outbreak that can't be contained. Until the mutation that changes everything. Until the day when hope isn't enough and we're forced to confront the consequences of 25 years of neglect. That day may never come, or it may be closer than we think. The only certainty is that we're not ready for it. Stay informed, stay safe, and demand better from the systems that are supposed to protect us. Because right now, those systems are failing the people who need them most.